So in this next part of the chapter, we're looking at rounding and estimating. And just as a quick recap, I don't think I really need to go over this in a lot of detail. Rounding to 2 decimal places, so we look at the third decimal place. If it's 5 or more, we round up, less than 5 round down. So there we have it, 4, which means we round down to 5.91. Here we have 12.002 to 2 decimal places. Third decimal place less than 5, so it stays as 12.00. You must put those zeros in because it says to 2 decimal places. We need some placeholders there. 26.896 to 2 decimal places. The 6 round up, so the 9 becomes 0. Carry over 26.90. Just looking at significant figures. So if we want to round 59,678 to 2 significant figures, then we look at the third significant figure after the first non-zero digit, so 1, 2, 3, which is a 6. 5 or more, we round up, so that becomes 60,000. Remember, with significant figures, we count from the first non-zero digit. So we're going to count from the 3, and we look at the third significant figure, which is a 2, less than 5, so we round down, 0.0034. That's often one that confuses people. So like I said, we've just remember your rounding and what it means and how we do it and the different ways of rounding, whether we're rounding to given number of decimal places or significant figures. Well, in the next part, we're looking at how to solve problems involving compound measures and working out the upper and lower bounds for a value that's been rounded. And this will lead on to working out things like the maximum possible area, the minimum area, perimeter, maximum, minimum perimeters, and so on. Just a quick recap here. You know that length is a measure of distance, but remember your standard units, these are important. Mass is a measure of the amount of matter in an object, and standard units, metric units, grams, kilograms and tonnes. Capacity, the amount of fluid that a container will hold, so we have our standard units, millilitres, centilitres and litres. And volume is the amount of space a solid shape takes up, so centimetre cubed, metre cubed and so on. And you need to make sure you can do these conversions, you need to know these. Another quick question here as an example. Stuart puts his honey into 1 pound jars, and we're told that 1 pound is 454 grams. How many jars can he fill with 10 kilograms of honey? So 10 kilograms, we first make that conversion. 10 kilograms is 10,000 grams. So we know we're going to do a division, and we've got to make sure our units are the same. So if 1 jar holds 454 grams, then the number of jars will be 10,000 divided by 454. And again, we had to change our units. So that will give us, on the calculator, it will give us 22.02643. So rounding that down, he'll get 22 jars. The next part of the question, B, he says he sells the jars at £4.50 each. How much money does he make? So straightforward calculation, 22 times £4.50, which will give us, I think if I remember rightly, £99. Again here, you've met these before, you know that speed equals distance over time, and we can use this triangle to help us derive the other formulae. So if we wanted to work out the distance, for example, we would cover up the distance, and we would get speed times time. If we wanted to work out the time, you know, cover up the time, that's what we want, and it's d over s, distance divided by speed. But you've probably met that in physics, and you've done it in maths before as well. Now you must make sure you remember the units, and it's meters per second or kilometers per hour. Similarly, we have density equals mass over volume, and our units are grams per centimetre cubed and kilograms per metre cubed. You must get those the right way round. And we have a triangle here to help us. Density equals mass over volume. And if we use a triangle, we can derive all the other formulae. Now you must make sure when you do these sorts of questions that you check your units. In this question here, we want to find the density of a piece of wood with cross-sectional area 42 centimetres squared and a length of 12 centimetres. So good, our units are all right there. And we're told that the mass is 693 grams. Using our formula, we know that density equals mass over volume, and it's either grams per centimetre cubed or kilograms per metre cubed. So we've got our grams and centimetre cubed, so we're all right, our units are fine. Okay, so the volume is going to be the cross-sectional area, which is 42, times the length, which is 12. So 42 times 12, that will give us 504 centimetre cubed. Therefore, the density is going to be 504. Got that wrong. The mass is 693. Density equals mass over volume. 693 divided by 504, which will give us 1.375 grams per centimetre cubed. Don't forget to include your units at the end. Now in this question we've got a car which travels 8 kilometres at an average speed of 50 kilometres per hour, and then it travels 64 kilometres at 80 kilometres per hour. So we want to find the average speed. Now we know that speed equals distance over time. So to work out the average speed, we want the total distance over the total time. Now don't fall for the trap of just adding the two speeds together and then dividing by 2. You do have to work out the total distance divided by the total time. Now in this question we can see we don't know what the total time taken is, so we need to work that out. So if we rearrange if speed equals distance over time in our triangle, therefore we can say that time equals distance over speed. So looking at the first one, he travels 80 kilometres at a speed of 50 kilometres per hour. So the time taken for that one is the distance, 80, divided by 50, and which will give us 1.6 hours. We're talking in hours here. And for the second part of the journey, he travels 64 kilometres at 80 kilometres per hour. So the time taken for that is going to be the distance travelled, 64, over the faster speed of 80. So we'll have 64 divided by 80, which will give us 0.8 hours. Therefore, the average speed is the total distance travelled, so we'll have our 80 plus 64 divided by the total time taken, 1.6 plus 0.8. So 144 divided by 2.4. Which gives us an average speed of 60 kilometres per hour. Again, like I say, the trap a lot of people fall into, saying, oh, average speed, I'll just add them two together and divide by 2. Wrong. You can stop now. You don't need to carry on with this presentation. Maybe stop now and have a go at some of the questions on this slide. But please show all your working out, and you are allowed to use a calculator. These ones really shouldn't take you very long at all. Now, if we've been given a number that has been rounded, so in this case we've been told that we have a number and it's been rounded to 5 to the nearest whole number, then there are lots and lots of different values that our original number could have been. So for example, 4.9, if you round it up, will give us 5. 4.87, round up, will give us 5. 4.61, when you round that up to the nearest whole number, you'd be given 5. And there's an infinite number of numbers that it could have been. Similarly, on the other side, we could have numbers bigger than 5 that have been rounded down to 5. So we could have 5.1, 5.342, 5671. That would still round down to 5, 5.48. And we could also have 5.4, 999999999, and so on, which would round down to 5. And although our number, the upper bound we shall call it, the largest number that could be rounded down is 5.4999999 and so on, just for ease we say that our largest possible number is 5.5. I know this might appear confusing because you would say, oh well, that rounds up to 6, but when we're talking about upper and lower bounds, we are looking at half a unit below the rounded number and half a unit above. So if we're writing this, we're asked to work out the upper and lower bounds for the number 5, which has been rounded to the nearest whole number. I would write my answer. I would say that it was 5 plus or minus 0.5. My lower bound being 5 minus 0.5, which gives me 4.5, and my upper bound being 5 plus 0.5, which should give me 5.5. And we understand that our upper bound, we understand this to mean that it goes up to 5.5 but doesn't include 5.5. So less than 5.5 in other words. And here we have this written down. Okay, just remember and try and understand. So here we have some numbers and they've been rounded, we're told, to the nearest whole number. Write the upper and lower bound. So for each of these we're going to add, so we're going to subtract 0.5 to find the lower bound. So that would be 6.5 and the upper bound would be 7.5. 7 plus or minus 0.5. Oh. And 11, the lower bound for 11 be 10.5 and the upper bound will be 11.5. So 11 plus or minus 0.5. And if we just look at the bottom one here, 100 minus 0.5 would give us the lower bound, so 99.5. And our upper bound will be 100 plus 0.5, so 100.5. And we write that as 100 plus or minus 0.5. So here, if we were rounding a number to the nearest 10, so for example, a number has been rounded to 20 to the nearest 10, then our lower bound would be 20 minus 5 which would give us a lower bound of 15, and our upper bound would be 20 plus 5, which would give us 25. And we could write that as 20 plus or minus 5. Now, if we're rounding to the nearest whole number, we would add or subtract. Let's make it a bit bigger. So we have here that a number, if it's been rounded to the nearest 10, we add on 5 to find the upper bound and subtract 5 to find the lower bound. If we round it to the nearest whole number, we add 0.5, which is half of 1, to find the upper bound and subtract 0.5 to find the lower bound. If we're rounding to one decimal place, so 0.1 to one decimal place, then half of 0.1 is 0.05. So we're always going half a unit below and half a unit above, and that half a unit of what we've rounded to. So rounding to the nearest 10, we added and subtracted 5. If we rounded to the nearest 100, we would add and subtract 50, and so on. So here, if I've got a number that has been rounded to one decimal place, so we'll say 3.2 to one decimal place, then our lower bound is going to be 3.15. And our upper bound is we're going to add 0.05, so we get 3.25. And we could write that as 3.2 plus or minus 0.05. So here we've measured something to be 5 centimetres to the nearest whole centimetre. So the smallest length that this could be would be 5 minus 0.5, which would be 4.5 centimetres, and the largest it could be would be 5.5 centimetres, or just a little bit less than that, so half a unit above. And writing this as an inequality, we would say that our measurement is greater or equal to 4.5, but less than 5.5. So measurements, what we can take from this is that measurements are not exact and so are rounded, and this rounding causes what we call an error interval, which has an upper and a lower bound. If the width of a book is measured at 16 centimetres to the nearest centimetres, then from what we've already learned is that rounded to the nearest whole number is 16. Then if we go half a unit below, the lower bound for the width would be 15.5 centimetres, and the upper bound would be 16.499, but we say 16.5 as the upper bound, and we would write it as an interval here. So the width is greater or equal to 15, but remember is less than 16.5. You may like to pause the video now and just have a go at some of these, but I'll write up the answers now. So rounding to nearest 100, we're going to add or subtract 50. So the lower bound will be 3,350, and the upper bound will be 3,450. 32 to the nearest centimetre, so we're going to add and subtract half a centimetre. So the lower bound would be 31.5 centimetres, and the upper bound would be 32.5 centimetres. You should really remember to put your units in. 300 to one significant figure. So this is like rounding to the nearest 100. So here, half of 100 is 50. So the lower bound is going to be 250, and the upper bound is going to be 350. 23.8 to one decimal place. Then I'm going to add or subtract 0.05. So the lower bound will be 23.75, and my upper bound will be 23.85. 7.89 to two decimal places. So I'm going to add and subtract 0.005. So my answer for this one will be 7.885. and the upper bound will be 7.895. So in this example, we've got a gardener. He measures his rectangular vegetable patch to the nearest metre, the nearest whole number. It measures 10 by 5 metres. What's the lowest possible value and the highest possible value for the area of the vegetable patch? Now, when we're multiplying, if we're working out upper and lower bounds, when we're multiplying, the smallest area or smallest value we could have would be when we multiply the two lower bounds together, and the highest area would be, the largest area will be when we multiply the two upper bounds together. So that's one rule for multiplying. The maximum is the two upper bounds multiplied together. The minimum when we're multiplying are two lower bounds. So my two lower bounds, so 10, if it's been rounded to 10, my lower bound is going to be 9.5 and my upper bound is going to be 10.5. And here, if it's been 5, my lower bound is going to be 4.5 and my upper bound will be 5.5. So when we're multiplying to work out the maximum possible area, I'm going to do 10.5 multiplied by 5.5, which will give me a maximum area of 57.75 metres squared. And when I'm finding the minimum, I'm going to multiply the two smallest areas, two lower bounds together, which will be 9.5 multiplied by 4.5 to give me 42.75. Now speed equals distance over time. So you've got to think about this. If we want the maximum possible speed, we want the largest number divided by the smallest possible number. And in a fraction, the smallest fraction we have is when we have the smallest number in the numerator over the largest possible number in the denominator. So for a maximum value when we're dividing, we want the biggest over the upper over the lower bound. For the minimum, the lower bound over the upper bound. So you do have to just think about what you're doing here and don't just think carefully. So if a car travels at 120 kilometres to the nearest kilometres in 1.2 hours to the nearest tenth, so to one decimal place, find the maximum and minimum values for the possible speed. So the maximum speed, so we're going to have distance over time, so the maximum speed is going to be the upper bound. So if we've got 120 to the nearest kilometre, my minimum is going to be 100. My minimum is going to be 119.5. And my maximum is going to be 120.5. And if we're looking at the time, I've got a time of 1.2 hours to the nearest tenth, so the minimum is going to be 1.15 hours and the maximum is going to be 1.25 hours. So my maximum speed is going to be the maximum distance, which is 120.5 over the smallest time. So working that out on my calculator, I shall have 120.5 divided by 1.15, which will give me 104.782. .8 kilometres per hour, and my minimum speed is going to be the lower bound for the distance, so that'll be 119.5 divided by the upper bound for time divided by 1.25. If I put that into my calculator, I have 119.5 divided by 1.25, which will give me 95.6 kilometres per hour. So when you're dividing, make sure you've got the what you're dividing, the upper and lower bounds that you're dividing the right way round. And here we have some general rules for finding upper and lower bounds. So addition and multiplication, the maximum you're going to add the two maximums together to find the upper bound, and the minimum values add the two lower bounds. And if you're multiplying, it's the like, so two upper bounds multiplied or two lower bounds. When you're subtracting, to get the maximum possible value, you want the upper bound minus the lower bound, and the minimum value would be the lower bound minus the upper bound. Think about a small value, take away a bigger value, you end up with a smaller answer. And division, we've just done, maximum is largest over smallest, and the minimum smallest over largest. Now you've got to read the questions carefully. Now here it says find the upper and lower bounds for these measurements which are correct to the nearest 5 millimetres. So we've had something which is rounded to the nearest 5 millimetres. So half of 5 millimetres means we're going to add or subtract 2.5 millimetres to find our upper and lower bounds. So 55, our lower bound, is going to take away 2.5 millimetres. We'll get 52.5 millimetres. And our upper bound is going to be 57.5 millimetres. If something's, you might find it easier actually to, so if we're adding or subtracting 2.5 millimetres, that's the same as adding or subtracting 0.25 centimetres. So here, 34 minus 0. centimetres minus 0.25 centimetres will give me 33.75 centimetres, and my upper bound will be 34.25 centimetres. And if we're in metres, we're going to be adding or subtracting 0.0025 metres. So 0.3 metres minus 0.0025 metres would give me 0.2975 metres, and 0.3 metres plus 0.0025 metres would give me 0.3025 metres. So you've just got to think really carefully about units and what is going on. So in this example, we've got a toy car travels 4.5 metres in 2.3 seconds. Both measurements are given to one decimal place. Find the upper and lower bounds for the car's speed in metres per second. So our units are fine. We've got metres and we've got seconds. Now 4.5, my lower bound is given to one decimal place. So my lower bound for speed is going to be 4.45 metres, and my upper bound is going to be 4.55 metres, and the time taken 2.3 seconds. My lower bound is going to be 2.25 seconds, and my upper bound is going to be 2.35 seconds. So we know that speed equals distance over time. So if I want to work out what the lower bound for this car speed is, so the lower bound will be speed. So I want the smallest distance over the largest time. Smallest distance, sorry, this is my distance here, and this is my time here. So my smallest distance is going to be 4.45 over the largest time divided by 2.35. If I work that out, I've got 4.45. Which is 1.89 meters per second. And if I now do my upper bound for speed, do it in red. The upper bound is going to be speed. I want the largest distance, so 4.55, divided by the smallest time, 2.25, which will give me 2.02 meters per second. Now that's it as far as the theory goes for this, so you could make sure you finish off the questions in the earlier slide, and in addition there's some questions here I'd like you to do, and finish off these questions from earlier on and do these in addition, and do whatever others you feel. If you want to get more practice, then feel free to do any other questions that you like.